This video will show you how to perform 4 common calculus operations in the TI Inspire calculator. We'll learn how to graph a function, evaluate that same function in a calculator page, take a symbolic derivative of that function in the calculator page, and evaluate that derivative. So we're going to use this function, which is a cubic, and we're going to do everything at the point where x equals 3. So I'm going to go to the calculator and enter my function in the calculator page. So x cubed minus 4x squared plus x plus 6. And I see that I have a cubic function there. I've got 3 zeros, and x equals 3 is right here. So I've entered the function in a graph page. I'm now going to go Control plus Page and add a calculator page. So I'm in a calculator document. I'm in problem number 1. The graph page is page number 1, and problem 1, page 2 is the calculator page that I'm in now. I'm going to go to this key marked var. It stands for variables, and I see F1. So that's the function I defined in the graphing page. So I'm going to hit enter, put in a 3, and I find out that my function when x equals 3 equals 0. So now I'm going to go to this key, which I call the palette-o-math stuff. I hit that key, and this palette of all these different things I can do in the calculator comes up. Right now, the d over d blank is highlighted. That's the calculator's way of saying I'm going to take a derivative. So I hit enter, and I've pasted that derivative operator into the calculator screen. So I'm going to tell it that the independent variable I want to take the derivative with respect to is x. To move between templates, the best way to do it is to hit the tab key. Since I've already defined the function, I'm just going to put in f of x and hit enter. So the derivative is 3x squared minus 8x plus 1. We could have done that by hand using the power rule as well. I'm now going to go up, grab that same expression. I go to the control key, hit the control key, and then hit the equals button. I call this the inequality palette, but the lower right-hand side of that is a vertical bar. In math language, that means such that. Then I'm going to put in x equals 3. So I'm saying this expression, substitute in x equals 3, what does it come out to? So I hit enter, and it comes out to 4. So that is the slope of my function at x equals 3. And I can now go to a clean page. So I know I have the point 3, 0. So that's an x coordinate and a y coordinate of my function. We got the derivative at x equals 3 was 4. So that's a slope. If I want to write the tangent line to my function at x equals 3, y equals 0, the best way to do that is using the point slope form. So this is the point slope form of an equation for a line. And I've got everything I need here. So it's going to be y minus 0 equals the slope 4 times x minus 3. And that is the equation of my tangent line. I can verify that by going back to the calculator, back to the graph screen. So 4 parenthesis x minus 3 graph that line, and I see that it is actually the tangent line. And if I check further, so get an intersection of the two functions, and I find that they intersect at 3, 0. So to review, we've covered graphing a function in the calculator and a graph page, evaluating that same function in a calculator page, taking a symbolic derivative of a function that we've entered in a graph page, and then evaluating that derivative in the calculator page.